Hello everyone and welcome to Python's Freedom 2020. My name is Andrey and I'm very happy to introduce for you our next speaker today. Andrey Devyatkin is a systems engineer and public speaker. He worked as a software developer for companies such as Ericsson, Pragma, Atlas Copco and Volvo Trucks, just to name a few. Now Andrey is a senior cloud engineering consultant focusing on building cloud-native application delivery platforms that enable rapid iteration, data-driven decision-making, and experimentation. Andre, most welcome, and I give the word to you.
All right, thank you for introduction. Let's get to it. Today we are talking about looking for the needle in the haystack of the HashiCorp Vault audit logs. And I often say that every cloud specialist, every cloud engineering specialist is a data science, security in the cloud becoming such a big part of our everyday life. And today we're gonna dive deep into this topic. Again, about the security, I like to use those two sayings that there are two types of companies, the ones that who have been hacked and the ones that who don't yet know that they have been hacked. And as another guy said, you see, it's even emerging into another category where there is a company that have been hacked and they're going to be hacked again. And we don't really want to be there. So using tools as like Vault helps to figure out what's going on in the system and keep your organization secure. So, and if you are not into the cybersecurity landscape in any sense, if you're just a developer but like to get a picture of what it's all about, I do recommend those two podcasts. They're quite amazing, going through the history of different hacks and explains how people got into the organizations, what their goals were and what they achieved. So that might help you to develop a better and more secure software. And you know, there is nothing new in using tools like pandas and to analyze cloud security events. If you ever worked with AWS, there is a thing called CloudTrail that records. Hopefully you have it enabled. If you don't, well, go now and enable. You can finish this presentation later. CloudTrail is a service that records everything that's happening in your AWS environment. All API calls done via the CLI or web UI or maybe your application calling something, everything is recorded and then stored to S3, and then you can use Amazon Athena to analyze the logs and send them to your security team. But what you could also do is you can use Pandas, and Pandas has a connector to Athena that allows you to run Athena queries, and Athena is a service that can query data on S3 that could be stored like in CSV or JSON files. And for Athena, it would look like the big SQL-like database. So you can run SQL-like queries, stores your S3 buckets, get the data, and pre-aggregate them and then load them to Pandas for further exploration, or just pass them by to your security team. And I thought to actually apply the same type of thinking to the HashiCorp Vault and its audit capabilities. About myself, my name is Andrey Devyatkin. I'm a cloud engineering specialist and I am specializing in AWS and building application delivery platform using HashiCorp tools. I'm co-founder at 5XL, a cloud engineering consulting firm. I'm also a public speaker, so doing those public events like this one quite often. And I do share ideas and also host a DevSecOps Talks podcast. So if you like what you hear today, tune in to DevSecOps Talks podcast on your podcasting platform of choice. It should be available there. So what to expect today? I'm not in any way pretending to be an expert. I'm basically doing the act of public learning. I'm sharing what I'm learning as I go. There are going to be technical details, quite a lot of them, but don't worry, the slides will be available online as well as YouTube recordings, so you can always go back and rewatch certain moments. So just relax and enjoy. What is the problem, right? So why would people use Vault if they're already in AWS, for instance? Well, it could be so that might go multi-cloud. A lot of people talk about multi-cloud, but no one really does it. What people do, they might do a hybrid cloud where they might have some GPUs sitting in their local data center because those are too expensive to hire from the public cloud, and then they might have the rest of their IT environment in a public cloud. So then you need to connect, and then you will need to have a way to audit events across the multiple environments like AWS and your private data center. Also, even if you are on AWS, you might be using self-hosted services, so you might run some certain self-hosted applications, for instance, MongoDB, and then you need to get insight into what's going on in that database, right? You might want to access a third-party service, or you might even have a native service like RDS on AWS, but you still don't have insight who is logging in into RDS and what they do. That doesn't go into the cloud trail. They would use like MySQL or PostgreSQL accounts, and there is no audit. Quite often organization might have one database login and password for everyone, for application, for developers, so you have no idea who is logging in and running those operations. So what we want to achieve is we want to have secure and auditable storage of sensitive information, right? If we are subject to any type of compliance regulation like GDPR, PCI DSS, HIPAA, then quite often you have to produce the reports showing that no one touched information that they shouldn't be touching, and if they touch that information, they had authorization to do so. So how do we do that? And this is where the HashiCorp Vault comes into play, because it allows you to fight the secret sprawl, to keep everything in one place. It allows you to shift from static to dynamic secrets. We're going to see how it works soon. It also gives you a possibility to stop sharing the plain text secrets, which is amazing. Also, due to the usage of dynamic secrets, you have a break glass procedure, so you could actually revoke certain secrets or just close your secret storage if there is something going on in your environment. You could use that to protect it across multiple clouds or hybrid cloud environment. And it has audit trail, and we're going to look a lot into audit trail today. But before we do that, I want to walk you through a couple of those points and show how they work in action. So, for instance, Vault can be used to store key value pairs. And this is how you do it from CLI. You could do exactly the same from Terraform, for instance. You can use HashiCorp Terraform to configure Vault. But if you don't, then you could use CLI or some other tool. So here we are enabling the secret engine called KV, key value store, and then we're using CLI to write a secret there, which has a key, my value, and a value, so digits and symbols, and then we can read it, so we can get it back. And this could be done by humans, or it might be done by the applications. And there are a lot of secret stores that can do exactly that, so nothing fancy at this point, really. Here's the interesting part, and this is where people quite often come to the Vault. So we are enabling database engine, and then we're configuring it, saying that we're going to use a certain type of database, for instance, PostgreSQL. That's a connection URL to my database, that's allowed roles, and that's my username, that's my root username and password in this database. And we tell Vault to rotate my root password, and this way only Vault knows your root password, so you cannot lose it. You cannot lose something that you don't have. And now what we could do is we configure Vault to issue temporary credentials. So we're creating a role to this database. Here we're passing creation statements, and we're setting a TTL, time to leave. So those credentials will be valid for 1 hour, and after 1 hour, if you don't renew them, Vault will revoke them, and they could be maximum renewed up to 24 hours. And now we just go Vault read database creates my role, and we're getting the password and username. Those were generated by Vault. and they will be valid for 1 hour. Just imagine how powerful is that. All your applications can get a separate login and password. All your operators, developers can get a temporary password, and Vault will record who got that password. So you get an idea who is logging in your database with much more precision comparing to when you're using the shared password, right? It's just really great. You could do the same with AWS. The logic is the same. We're configuring the secret engine. We configuring the credentials for Vault to use when it goes to AWS to provision credentials for us. We deploy in the role, and then we can, well, the syntax is different between the secret engine. So in the previous one we read, and here we write, but we are basically getting the AWS access keys that we could use, and they're also valid for 60 minutes and could be renewed. Also, we spoke about possibility to prevent people from sharing plain text secrets. We do that with a transit secret engine. So we create an encryption key here, and Vault can support a lot of different key types with different ecliptic curves, if you like. Now we just creating like the default key. I believe it's IS 256, but I might be wrong about that, so you have to check it. And then we writing something. We're saying please encrypt using this key. We're passing the plain text, and we're getting encrypted text. Now we can send this text in Slack, for instance, or in email or whatever, and then we could the receiver of the text could use Vault if he has access to the same key to decrypt it and get the data back. So you have an encryption as a service, which is quite powerful and enables a lot of scenarios. So now imagine that like you have all your workloads having those temporary passwords, and you get an intrusion. You see that the certain set of credentials are misbehaving. They exhibit the unusual behavior, which means that you can just revoke those and leave everything else running. No big deal. Imagine if you use the shared login and the password to your database, and that's used by developers, but by the applications. You cannot just revoke it. You're going to break everything and cause production outage. So by the switching to the dynamic credentials, you're actually getting a break glass procedure. And also what you could do, you could revoke all the leases. If things are getting out of control, you just revoke everything and seal the vault. In this way, intruders cannot get access to your crown jewels stored there. Also, I said that it could be used to protect sensitive data across the clouds and private data centers. You could deploy Vault wherever you like. And on the HashiCorp last year, I saw an example from one of the Norwegian agencies using the Vault to comply with GDPR. So what they did, they used transit secret engine to encrypt the data in database. So they don't store plain text stuff in the database. They pre-encrypt and already store encrypted text in there. And when they need to forget the people, so if person exercise the right to be forgotten, then they just delete encryption key and they don't need to delete anything from database. The data stays there, but they cannot decrypt it. So it's basically lost. And finally, we're getting to the juice of the presentation, audit trail. That now we could see what everyone is doing, and this is what we're gonna get. We're gonna get a JSON record that looks like this, right? And we understand who is coming in, what the person wants, what was the data. So how do we process that? Well, before processing, we actually need to enable that, and we can enable by this command. And always on all the slides, I have a reference to documentation, so you could find more information there. It's right here. And we can enable it this way, or we could use a Vault configuration file on a startup. And HashiCorp recommends that you store your audit files on a disk. So it's not a blocking device. And then the question arises, well, how do I get my audit files to data lake? And that kind of depends on how you deploy Vault. if you like running on the virtual machines, you might use something like fluentd, or you might try to send the data to the syslog, those to the syslog. So there are different options, but imagine you're storing that to S3, right? So we comply with the example I showed you before, and then you can use Athena, or you can just download everything straight away and start analyze files using Python. Also, there is a tremendous resource called learn.hashicorp.com, and they have a lot of interesting scenarios there that you could follow and learn more about the Vault. So quite a lot of examples here were actually inspired by one of those scenarios, and I'm using their data set for my demonstrations. So I'm downloading the data set here from GitHub, and then, as you could see, I'm running the small script called vault.etl.py. I'm taking the log and I'm converting that to Parquet, so it's easier to check. And I could see that in this data frame I have almost 1500 rows, so not a big one, but big enough for demonstration. This is a script. Nothing fancy happens here. Again, don't pretend to be a Python programmer, and also not pretending to be a Pandas super user, so I'm pretty much getting started there. So what's happening is I'm supporting two cases. I'm supporting if there is a directory, then I would just go all over the files in there and use and process all of them, or I would just get, if I'm just getting a file, then I just process that file straight away. And in that file I might have one JSON record as a one line, or I might have many, so I have to open the files, read them one line by line, and then I use pandas JSON normalize to flatten it, so I could address JSON nested fields. Let me show you. So here, for instance, I have auth.client token, so I want to access those one, so I need to normalize the JSON. So I have a flat structure, a table basically. And then I just writing that to Parquet, and that's pretty much it. And also I'm dropping the data of the response and request. I'm not interested in those at the moment. That makes a data set smaller and faster to work with. So now I just gonna start interpreter. I'm gonna load the files that I prepared and gonna do some explorations, right? So the first thing I could do is just to understand how many response requests I am getting, and the numbers. Another thing I could be doing is I could go deeper, right? So I could see what type of the operations I have. And now I see, all right, so I have some updates, reads, creates, leads, deletes. So if you take it out of context, it's not very useful. But if you have month-to-month data, then you can find the spikes. And if you get the spikes, that's something unusual, and that's something that you have to investigate as a security analyst. Now we could see who actually went into Vault, right? We could see the display name attached to the tokens. And here I actually spot something that draws my attention. I haven't worked with this data set. I don't know where it's coming from, but I could already start to analyze it and draw some conclusions. So I could see that the root token being used, and it's being used 21 times. This is something that we strongly discourage, because root is a god mode in Vault. So you could do whatever you like, and that's very dangerous. So we always recommend revoking all root tokens that you got and never use them, and just create the service roles and use those. So here someone actually used the root. Let's see what they did, right? We could do like this, and we could try to see what every display name did. And this doesn't really answer all of our questions, because the number of rows here are skipped, so we don't see all of them. And let's just zoom in to the root and see what actually root did. So if we just filter out our display name root and pick those fields out of the data set, we could get a quite good picture and understand what was happening. So we could see that someone using root token actually configured the audit. So something happened here, we don't really know. Then they updated the policies, they created additional roles, they checked their own tokens. So you see, like, we start to see a scenario. We can probably follow what they did and dig deeper into the data set to see what exactly happened here, because we can also check the response data and the request data to understand what exactly they did with a certain path. And everything in Vault is passes. That's why it's so handy to analyze. Well, another thing that security analysts are usually looking for is errors, right? So they would like to see what is wrong, what is going on in the system. There might be some permission denied issues, right? So maybe someone is trying to figure out what's going on in the system by poking into different passes, and we doing the query in a data set. We're checking the error field, and we're checking that it's not null. There could be other ways of doing that. And here we're just getting some basic information to understand what happened. And we see that, yes, there was some permission denied, there was like missing client token, but there doesn't seem to be that many, right? So it's probably nothing to worry about. It might be just a developer trying to do something, but, you know, bumping into some problem, or maybe he forgot to renew his token, or maybe he forgot to get a new token. Who knows? But it's happened like once or twice. That's not a biggie. We don't really see a scanning behavior here. So we could say, like, right, so that looks normal. We could also check who was there and see that all of those were maybe coming from the different people, right? So if you take also display name, oh, we actually have it here, right? So we didn't have anything, so we could draw a conclusion that there were like no token used. And here we had a token, but it requested some unsupported path. So nothing to worry here. That all looks good. Another thing that we could investigate, we could see for the IP addresses. So we see what are the IP addresses that's being used to access Vault. That's useful. So 10.10, that looks like a local IP network, which means that most probably all of those requests came from the internal network. It's good. You don't really want your Vault to be exposed to the outside world, since you have all your crown jewels there, and there are always people who are scanning all IP addresses in the internet trying to find what they can poke at, and you don't want them poking in your secret storage. So keeping that behind the closed door, it's a good idea. Also, this data could be used to find outliers, right? So we could see that the majority of requests came from here, but there are some requests coming from here. So then we can drill down and try to understand why is this so, because there seems to be a lot of requests coming from the same IP address. It might be so that there is some very active application living there. It might be so that the Vault just got up and got configured from this IP address, and those are legitimate users. We don't know. We need to dig deeper. But the good thing is that we have a data set already available to us, and we can use pandas to drill down even more. Well, it could be so that we just need to find what some person did. And as you noticed, Vault in its audit log, it's using HMAC SHA-256 to hash all the possible sensitive data and the token. And the token is something that you use to authenticate in Vault, to interact with Vault. Vault token has a policies attached to that, and policies tells Vault what you could do and what you cannot do. And as you could see, the token here is hashed, so we don't really know what exactly the token is, but and it's also hashed with salt, and the Vault has that salt internally, but it has there is a CLI call that you could use, a CLI command that you could use, or API call that you could use to ask Vault to hash any type of data in the same way, and then you can produce and match those hashes. So for instance, if you know the offending token ID, you can hash it and then look for it in the data set. The same happens with the request and response data. Those also hashed. So you don't get to see the secret stored in Vault when you're analyzing the audit logs, which is good. But you have possibilities to guess them. So that's why, I mean, you can still try to guess the hash, and that's why you still have to be vigilant about the audit logs and who has access to them. Also, there might be a malicious actor within your organization or intruder who might try to alter the audit logs and make you blind in that sense, so you don't really see what they did. You could also try to use Pandas GUI to do a little bit more graphic exploration. But look at this, if you take the data frame as it is, that's not gonna fly. Well, let's see why. It says here that we have a data in unhashable type. I guess people who work with pandas and analyzing data, they kind of nothing new to them. And let's see where we have it. We do have arrays here in policies and token policies, and that seems to be it in this particular example, but we don't really know, right? So it might be so that there would be other fields and we want to play safe. So thus we just go all over every column and apply lambda that will just take arrays, join them into the string, and if it's not array, just keep it as it is. Again, not a pandas expert, probably a better way of doing that. So reach out on LinkedIn, tell me. Or using any other way. You could also use mail address down on the slide. So now we have Pandas GUI running, and I'm not planning to go into much detail in here, but you could also build some graphs and gain more insights through the GUI if you like to, or if you like Jupyter, you could use Jupyter for exactly the same purposes. So also now when we fixed our token policies, we could do value counts. We couldn't do that with arrays, and we could see what type of the policies being used, and we could see that the root was used 21, and that's matches with what we saw before. That's a good thing, so there is no irregularities. And then we see that there is a lab user being used and there is an admin role, and everywhere default also being used. So we usually recommend just drop default, and because it might have some umbrella policies in there. So there is something to learn even from such small snippet of information, maybe advice to people who runs that particular Vault instance. So next steps, those slides as presentations pretty much live. It's evolving from presentation to presentation. So hopefully next time I hope to present a comparison between month-to-month data, do a little bit more dashboarding, do a visualization, probably shipping somewhere to maybe Elasticsearch, doing the dashboards in Kibana for the security team, and also look into anomaly detection and alerting for that. So this is like what's on my roadmap, working with this. I was trying to find stuff on online, couldn't really find it, and that brings me to the final thoughts. And one of the things I wanted to mention here, I strongly encourage you to go out, to reuse and share as much as possible. Everything I showed here is available on GitHub. If you go to the GitHub/5xl.io, I believe, you will find the stuff there. Also, I had a link to GitHub on the slide with a Python program. It was to a particular version of the program that I used to prepare this presentation. Going back to Vault, the Vault introduction is a journey, it takes time, and I saw people spending actually a couple of years to figure out how to introduce that into their development process, since they so used to think about the secrets in a static manner. So what I usually recommend people is to look for some use case, some business case that would make a difference for them and go for that particular thing, make that work, and then expand from there. And if you have Vault, if you succeeded installing it within your organization and integrating that in application development process, that gets your developers a really solid foundation for building security first application, right? So you can use Vault to build this platform and let your developers do right thing. You always want to do right, you always want to allow, or you always want to make right thing easy to do. This is what I want to say. And then, learn to work with data. If you are a cloud engineering specialist as myself, well, it's very useful. You could use it for CloudTrail, you could use it for S3 access logs, you could use for VPC flow logs, you could use for the HashiCorp audit logs. It generally helps you to keep your organization safe. And you know what? In like 2, 3 years, 5 years, maybe public cloud providers will automate us out of the job. Who knows? Maybe there will be no need for cloud engineering specialists, or like some people call them DevOps as well. But then we know how to work with data. We can always go and work with data. There seems to be a really big shortage of the people who work in that field. So a good skill to have in your toolbox. With that, I'd like to finish for today. I'd like to thank you for tuning in, listening. If you have any feedback, if you know how to do any of those things better, or maybe run some other queries that might be interesting to you, reach out to me. You have my contacts here. You have a Twitter. You have a 5xl.io. That's a website. That's my personal website. Both has a contact button. You can reach out on LinkedIn. And the last link that you're going to see soon, right now, that's devsecops.fm. That's a podcast that I'm recording together with my friends. And there are quite a lot of topics covering building security into your application delivery platform. With that, it's all I got. Let me see if there are any comments or questions on YouTube.
Yeah, good.
Thank you very much
Thank you very much for your presentation. And people also can ask questions in Slack, if I will have it.
If anyone have any, feel free to write them on YouTube. We're gonna get them here, so I will answer them straight away. If you want to make it in private, the contacts on the screen.
Yeah. Thank you very much, and thank you for being with us today.
Thank you for having me, and enjoy the conference. Bye bye.
Bye bye.